Thank you. So, hello everyone. My name is Katarina. This is Ivana. We are from the University of Zagreb, from the Faculty of Electrical Engineering and Computing. And today we will talk about our doctoral research, which is for Ivana MaaS, for me IoT. But we are discussing how we can combine it and use the strengths of both to create a valuable product. So the presentation. Okay. So the lecture content is, we'll start with MaaS, then by Ivana, then I will talk about the Internet of Things, and then we will discuss how we combine MaaS and IoT together and how we use software agents to do so. So now we'll Ivana start with MaaS.
Do you hear us, or you would like to?
Yeah, it's gonna be fine in a minute.
Okay.
So let's start.
My theme is Mobility as a Service, or shortly MaaS. I will explain everything behind this name. So, let's talk about Valencia. I took it as an example. As you already know, it is situated on the eastern part of Spain, and we all together arrived by plane to Valencia. And we see all the beautiful components of Valencia, some such as cultural, historical monuments and so on, food, paella valenciana, etc. But this is one prettier part of Valencia. However, there are other problems such as congestion problem. As you can see on the left photo and on the right photo, you can see a map of Valencia in afternoon part of the day, and you see these dark red spots and red and orange spots, which represent the part of the road that have difficulties in transport, and the velocity is drastically slowed down because of the congestion. The congestion problem is not a problem only for Valencia. There are other problems in transportation sector. For example, there are also traffic jams in Bogota, in Colombia, and there is estimated that 191 hours a year is spent in traffic jams, which is approximately 8 days. And there are also other problems, such as the problem in United Kingdom, where they spend approximately 44 hours a year just searching for a parking place. There are other problems such as environmental and noise pollution problems, and, for instance, higher traffic costs and so on and so on. As you can see from this data, the problems in transport is not characteristic only for Valencia, it is the issue for whole world. So, what is the reason for all of these problems? It is caused by the urbanization. As you already know, that is the process of expanding cities, transforming rural areas into cities, and an increase in the urban population. And by United Nations, they estimated that in 2018, they were 55% of urban population, and they estimated that in 2050 it will be 68% of whole world population will be living in urban areas. And therefore, they raise the issues or challenging future needs for housing, transportation, energy, medicine, schools, and so on. And they emphasize that it is important to manage all of these urban growth things. By this presentation, we will focus on transportation. And regarding all the problems, there's one possible solution that is called Mobility as a Service, or MaaS. And let's explain the definition behind this. That is a concept in which different transportation options, such as the car, bikes, public transport, and so on, are integrated and offered to the users, to us, in order to meet their mobility needs. It relies on digital platforms such as mobile phones, and where the provision of transport is managed, and payment and booking services are integrated as well. I will explain this with one example. If you want to get from point A to point B, you just need to take your MaaS application. You type the starting and destination points, and MaaS will offer you a few options. For instance, there is one option where you can cycle a few meters, then you can take a bike. After what you need to take a public transport, and at the end you will take a car sharing option. And for instance, these options suit you, and you just book it and pay for it. That is the idea behind the MaaS concept. But we need just to check what are the main actors of this whole MaaS concept. There is one model that is called Quadruple helix model. That is some specific model that represents all the actors that are collaborating together to create social innovation activities. And this social innovation that is in the center of these actors try to satisfy the social needs and improve the quality of life. So let's map this quadruple helix model that is general to the MaaS. So in the center we have, instead of social innovation, we have MaaS. And what is the civil society? Those are the passengers. Who is the industry? You can just say what you think is the industry, like in MaaS. Those are the transport operators. Government is still government because we need some regulations, and there is academia. We'll discuss a little bit about these slides. Okay, so they are all acting together to make social innovation. In this case, that is MaaS, and they are all giving something to MaaS and also receiving back something from MaaS. For instance, what do you think about passengers? What they are receiving from mobility as a service? Yes, transport solutions.
Time.
What?
Time.
Time, yes. What do they give to MaaS?
Money.
Money, okay. And what is another important thing for MaaS to function well?
Feedback.
Okay, feedback.
Data.
What?
Data.
Yes, I think the data is the most important part about that. Okay, what about transportation option? If you have some buses, why will you enjoy MaaS? What you receive from MaaS? What you think? For instance, you can reach more customers because, for instance, you can book your travel trip only on the reception. Now you will have application and everyone can book your trip with the application and so on. So you receive bigger customer market with new clients. And also what you give also data as the passengers, and also you give different forms of mobility with acceptable price. Okay, let's go to academia. They can give MaaS regularities because there are different stakeholders and actors, and it's important to be regulated. And they receive congestion reduction because with this there is no so much cars on the road. Also space optimization and economic growth. And academia. We are representatives of academia, so what we can give to MaaS, we can give research and knowledge, and we can receive more audience who will read and use our algorithms, and interdisciplinarity because we use our knowledge with the transportation part. Okay, this is all great, but there are a lot of challenges regarding MaaS. The first one is security, how to protect all the data and all the options and everything which is integrated. Also, data privacy. GDPR is everywhere now. Everyone needs to follow the guidelines of the GDPR. What about data aggregation and usability? With a lot of passenger and transport options, we aggregate a lot of data. How to manage all of this? Okay, about API standardization. Everyone will need to have data about their trips. How to get all data. Everyone has some specific types of data. So it's important to standardize API options. What about readiness to move up from classic mobility? What do you think about this? Does anyone has a private car? Or no? No one. Okay.
Private car.
Yes, that you use.
I have one.
Okay. Will you move from your private car and use just public transport or use bicycles? Will you use MaaS? Yes, you are ready to move from the private car.
Yeah.
Yes, you are. But for instance, there are some old people that are used to their private car, so probably they won't. What about willingness to pay? What is the price that you will like to pay for that traffic solutions? What about transport operators? And what about their adaptation? What they can get, what they can read, and so on and so on. Okay, the another problem is routing strategy problem. There are a lot of transportation options, a lot of passenger, and how to manage, how to make the best algorithm to suit the both needs. There is also electric vehicles. What about them? They have specific requirements regarding their battery capacity. So we need also to take that into account. What about autonomous vehicles? Autonomous vehicles are great because there we do not have a driver, we just have a passenger, but it separates us from car ownership, but we are still car dependent. Okay, and to conclude all of this topic, we can say that urbanization process brings challenges to the transportation sector. World is facing with different congestion problem, pollution, transfer costs, and so on. And with MaaS, it seeks as a promising solution. And if we understand MaaS stakeholders and their needs, we can maybe understand MaaS and implement it in our cities. And I think that MaaS brings us a lot of challenges, but I think we need all try to fix them and to implement MaaS. Okay.
So, MaaS. Right now, what Ivana explained you is what you have in Google Maps. You can put in your starting point where you want to go, and you will have a few options by walking, car, public transport, and so on. But this functions just on the data that is static and available through Google Maps and so on. So Internet of Things can do a lot of good things for MaaS and enrich it with more data, so you know if bikes are even available at the station and so on. So it's not like you arrive at the station, there's no bike. So Internet of Things. I heard that you had already a lecture about Internet of Things, so what is the main goal of Internet of Things? That is one thing you had to take away from that lecture. What is the goal of Internet of Things? Why do we do it?
To collect data.
What?
To collect data from everything.
Yeah, but what do we do before that collecting? Connect.
Yeah.
So the goal is to connect things so they're available everywhere, anytime, any place, and anything and anyone can be available. So anyone, even people, are now connected by smartwatches and stuff all the time, or smartphones and so on. So there are various IoT applications. Some of you already have smart gadgets in your home, like smart lighting, smart coffee makers, and so on. Then we have smart buildings, even smart cities, and smart cars, which Ivana talked about already. Then we have smart factories, facilities, and then even in our shops, we have now smart shops. We can order, pay, and stuff like that. And even in agriculture. So I'm employed as a faculty at an IoT field project that is all about agriculture. And so the goal is connecting. How many connected devices do you think were there in 2015, and how many are so to be in 2025? What do you think? How many are they? Does anyone have any idea? Billions, and even 75.44 billion devices are thought to be by 2025. There are many other researchers, some have like even more, some have less, but I chose this from statistics. And IoT is thought to be born between 2008 and 2009. That is the point where the number of connected devices succeeded the number of people on Earth. This is the definition, but I think you already heard it. Did you? Okay. So in a smart home, right now you have many smart devices. We call them smart just by connecting them to the internet. So does anyone have in their smart home like a smart lighting that you can control by your application and so on? What do you have? Philips Hue or something like that?
I have a smart outlet, but I built it myself, so it's
Yeah, sure. Still smart.
Yeah.
Does anyone else have anything like that? Coffee maker?
No, I have like this sun like lightning, you know. When
Yeah.
the sun comes up, the lightning was so.
Yeah, slow start lighting,
Yes,
like
yes.
that's like an automation. You can set it, wake up with the light. You see here.
Yeah, that's exactly.
Yeah. So it starts really slow and warm colors to wake you up and relax.
Actually, I got used to it. It's much better to get up and sleep like that.
Yeah, sure. So.
Already it controls my life. No.
Yeah. No, it's okay. So an application like this is the Philips Hue application, but in this application you have to put in everything. So you can combine some sensors like a pressure sensor in your bed. So when you get up out of the bed, the sensor will read that you're not lying down anymore. So the lights turn on. But all of that is like we automate it ourselves. So I make a rule in the application: when I get up, do this. When I pass into that room, sensors of movement turn on that light and stuff like that. So you have to put everything in by hand. So that is not the real goal of Internet of Things. We have to make it even smarter. So users want more comfort. My doctoral thesis is all about making those devices adapt to the user automatically by reading the environment, remembering his preferences, and setting the devices to accommodate him. So these devices have to be automatically set. So this is the already existing IoT architecture. I don't know how much you heard about it, so we will just go over it shortly. On the physical layer, we have devices like sensors and actuators. They're with limited processing power, not really powerful, but they're on low energy consumption, which is important. Then the network layer, the main goal is to transfer the data from the physical to the application layer. We can have some data processing here that is like, you know, many people have in their yards a light that turns on when there's motion in the yard. That is like that, the network and physical layer. And the application layer, where there is the real data storage and processing and all the services that we give to the user. But how do we make it even more smart? That is cognitive Internet of Things. So we will add a layer, that is the cognitive layer, which we will enrich with many other stuff. I will talk about it later. So here we have deeper analysis, reasoning, and decision making. And the application and data layer changed a bit. So there is no more network layer, so-called. We have already here some data analysis, and we take the data and make from it information and knowledge. So a sensor reading like 20 Celsius degrees doesn't mean anything if we don't put it into some context where we can use it after that. So the cognitive Internet of Things, what is used to bring it about: machine learning, artificial intelligence, context-conscious computing, big data analysis, cyber-physical systems, pattern recognition, computer vision, speech recognition. So this example with the smart light would be like, you wouldn't have to put in anything. The system would read your preferences, which you set once. and every other time the system would set those preferences at the context which you defined it above. And one step more is you see a lot of those smart home applications, but they're all for one person only. So what if you have many people in the room, like a smart office, and everyone has different preferences? You have to take all those preferences. They're like flexibility factors that users can define by themselves and get to a setting that will accommodate all users. So the conclusion about Internet and cognitive Internet of Things is that the best is yet to come. The potential of Internet of Things is not used in its full capacity, and it will come soon. So just to speak about two projects that I'm working on. One is IoT for Us. That is the smart human-centric services interoperable and decentralized IoT environments. So my doctoral thesis, which I talked about, is part of this project where we adapt all devices to the user in a smart cognitive way. He doesn't have to worry about anything. And of course, it has to be decentralized and interoperable and so on. And the other one is IoT field. It is for the agriculture sector. So we do a lot of things here also to help our agriculture sector. We also have a forest sense sensor in the making, which reads the health of the plant even before you can see anything on the plant by your eyes only. It's all very smart. So just imagine you have crypto. Everyone here knows about Bitcoin and stuff like that. Did you ever see that? Like, just for example, it goes like this. And everybody is like, you should have sold here. You know that. So we do this in agriculture. We have to guess the moment when it's best to plant the seeds and when it's best to collect the product. So that's the goal behind this. It's also a lot of cognitive Internet of Things included. So a little bit about MaaS and IoT together now. There was one project a few years ago. It was called Symbiote. It was all about MaaS and IoT together. So there were a lot of meteorological stations throughout the city, which collected the data about the air pollution. And the application would give you the best route based on the air pollution. So you would go to the cleanest route. That was one of the use cases. Next. So MaaS and IoT for cyclists, what the project idea would be. So we have bicycle renting. So you have seen this in Valencia. Did anyone use the bicycle renting system? Yeah. So how does it work? Can anyone say in a few words?
Particularly for me, I downloaded a mobile application and just registered a 1 week like subscription, yeah. And after I can unlock the bikes to the site.
Yeah. Can you see in the application if there are bikes at the station?
Yes.
Okay, so that
there are no bikes.
Yeah, so that is one of the use cases of MaaS. So you will recognize if there is a bike on the stand or not. And you can even reserve one so you can get there fast and it's not gone until you get there. So. The other thing is we worry about the health of cyclists here by using all those sensors that are fixed on the bike and fixed all around the city. So we can provide the bicycle riders with the best possible roads so they can drive the cleanest route. And then we can also, one other use case would be that humans have smart watches, so we can track their health, and then they can get recommendations about their transport regarding their health. So if someone was feeling not so good that day, had high blood pressure, the application will say, just take a taxi. No really need to ride a bike that day. That's it. So now I talk about another technology which can help us to make all this happen. So we will take every device and give him an agent, and every user will have an agent too. So software agents. Did anyone hear about software agents here? How?
Our university course.
Oh yeah, you're the university course. I'm the system admin course. So, what does a software agent? What are his characteristics? You don't say anything. What do you think a software agent has to have? I would say that he has to be good looking, has to know what to do in every situation, and how to drink a martini. How to drink a martini?
Ryan, not the start.
Shaken. There you go.
Okay.
No James Bond
I
fans.
failed software agent.
So no, this is not it. The three characteristics our software agents have had are the cooperation aspect, and the autonomy aspect. So from this three characteristics, we pull out a lot of other different types of agents, but the most important one is the intelligent agent, which has focus. So the intelligent software agents. Intelligent. So how does he come about that intelligence? We have a database that is important for him, learning capabilities based on those data and stored in the database, and decision mechanisms. So the database is is made of the knowledge about the owner and about the environment, so context, and that is changing every day, every minute, so it has to be able to adapt based on the changing data. Another important aspect of intelligence is autonomy. He has to be able to make his own decisions. So three aspects of autonomy are reactivity, proactivity, and cooperation. Reactivity is when something happens in the environment, a sensor reading changes, he will react to it. Proactivity is that he can make decisions to react based on nothing, just his decision. Nothing has to change in the environment for him to make a decision. And cooperation, he has to be able to cooperate with other agents. Another aspect, which is by some authors considered an autonomy characteristic, is mobility. We have users. This is a smart home example, not a smart MaaS example. User has his preference. And they can try to make their own decision based on their different preferences. But I think every one of us knows that when we are in a room and everybody is talking about their preference, we will maybe just step away from our preference to give more space to get to a together decision. So what can happen in those decisions? Somebody will not be happy at the end, or they can even fight. So we will change those users with user agents and let them fight their fights. So they can even have a little bit of intelligence by using artificial neural networks and stuff like that, and they can negotiate by their own. So now Ivana will talk about an example just for MaaS and agents.
Now just these agents will put in a MaaS perspective. So the focus of this especially agent part will be about car and about user, especially about the car, driving the car, and about user preferences. Why is this relevant to study for MaaS? This is relevant because we have a car and user in a different options, in a shared car, in a car, in a shared taxi, car sharing, taxi, ride hailing, rent a car on demand, right? Sharing, carpooling, autonomous car, and so on and so on. So let's see. So we need complex system. Complex system is in our case is the driver who drives the passenger, and we want to map this to a system model which is designed by agents. So we have agents and they have their environment. What is the motivation behind this complex system and why we want to study this? Because we want to characterize drivers driving. Also, we want to characterize passengers' ride preferences. And at the end, we want to study the different influential factors that makes those two characteristics. Okay, what is this is my doctoral thesis, let's say, and what is my research objective? So I want to see how to design one ride and how to design the passenger ride preferences. And what is the final objective of all of this research is to predict the passenger's level of driving satisfaction on the way the car is driven. So let's see. What I have of all of data, I have OBD, that is special component that you put in your car, and it collects the data about your speed, RPM, the position of your pedal, gas position, and so on and so on. Those are the parameters of a car. Then I have the data about location. So every 2 seconds I get the data about your location, also about signal in that part, sensor, traffic data, weather data, is it sunny, is it raining, and so on. And I also have a user data. Those are the passenger data and also the driver data. Okay, so I have car information, environment information, passenger and driving information. Okay, now I have a car, I have a driver in a car. Also, instead of the driver, we can have an autonomous car, but let's say that this is not in use. Then we have environment, and at the end we have passenger in a car. So let's map this to the agents. So in our agent domain, we will have agent car, agent driver, environment agent, and agent passenger. So let's see the characteristics of each agent. Agent has characteristics of a car, that is the type, the model of a car, and also has engine characteristics, which is driving speed, engine speed, and so on. We have environment characteristics, which are weather, time, road, for instance, speed limit, the speed of surrounding traffic, and so on, and also traffic. Okay. We have agent passenger. Those are the characteristics of a passenger, demographic, place of residence, driving habits, and so on. Also, we have ride preferences. For instance, some driving style that he prefer. Driving characteristics. It's not the same if I'm late for a flight and I need to hurry, so my driving preferences will change. And we have agent, which is driver. We have also his demographic characteristics and his preferences regarding driving style and so on. Okay, so this is our multi-agent system, and there are different agents that are communicating together, and they have their specific characteristics. It is important to say that all of these agents are collaborating together, and each agent has its preferences. I think it's just important to say that this agent passenger is important because it is interface agent that needs to learn. So on, he needs to collect data from the passenger and what is her preferences. So let's map this into real use case. For instance, we have Uber, and you have your passenger application, and you go to taxi, and after you finish your ride, you just put 4 stars regarding how it was your driver and the ride. Instead of this, with the agents, we can have agent passenger, that is specific component that can be integrated in a passenger application. Also, in a car, we can incorporate this agent and environment that will collect data from the environment. And also on the driver mobile phone, we can have the agent driver and agent car that can, for instance, those agents can send the data to the driver and told him, hey, okay, this passenger is like this and like this, please ride like this because he rates the best this type of driving, and so on and so on. Okay, and to conclude, this is one practical example of how to implement agent-based models in this, let's say, complex system. And with this, we can improve such systems like Uber and Bolt and so on. And for future it is important to collect more and more data, because if we have more data, we can include more things. And also, that's
So this was our work, so thank you for your attention. Ivana is part of the social app laboratory at our faculty, and I'm part of the IoT laboratory. But that's it about this part. But now we have a task for you about MaaS and IoT. So we want you to sit together with your university colleagues and draw out a MaaS and plus IoT ID. You have like 5 minutes for that. Or if you have something like that already in your city, explain that.
So you need this?
University, yes, university-based groups.
Yeah. So for your
city. Just in a few steps is your city ready for MaaS and IoT? Does you need to implement and to put some new things?
The city has, or what we would like to have in our
We don't have
Do you need more time or are you ready? So we have 1 more minute, so we can finish in time for lunch. Write down the signal and
It's not vocal, it's over toast.
So what's done is done. So just for reference, this is the Symbiote project we talked about in the presentation. This is a promo video, so you will see just about it. I'm just waiting for you to see the stations. Oh, these are the stations all around the city. I think this was set up in Spain. Okay. So that's it. That's one application you could have chosen in your presentation, but now we will start with University of Žilina. Where are you? You're the first on the list of members, so.
But we are the last, no?
No, first.
Okay. We should go.
Yeah.
Sorry.
So, what is your idea?
Well, actually, like Žilina is pretty complex and does have almost everything, except some exceptions. Well, we have like scooters, like bolt scooters, electric ones, but we think that the biggest problem with them is that you cannot park them anywhere you want. Actually, are very fixed to the parking places, and sometimes the parking places are located like 500 meters from the place where you actually want to go, so sometimes it's inefficient and usually it's a little bit more expensive, but when you're lazy you use it actually. So that's one thing. Then we have been talking about car sharing companies. That actually, me as a student in that city, like it's great that we have scooters, we have public transport and stuff like that, but if you want to go somewhere to the nature or close nature, for example, roller skaters to water dam, there is the path. You cannot really go that very easily because like there on the roller skaters it's up and down. So it would be nice to have an option to rent a car, for example, half an hour to move somewhere else. And also we mentioned that Uber would be perfect if we had more options, because right now we have like Bolt and the classical taxis. And the last thing is more bike roads or bike paths there, because there is like one main path very close to us, but actually around the Žilina I don't think there is that much as would be needed, and as would encourage people to use bikes instead of cars, for example, or public transport. Well, the public transport is green and pretty nice in Žilina compared to other cities, I think, so that's fine.
So where would you use IoT devices in all of those applications? Is there any application where you would use an IoT device?
Well, actually, everywhere you can have app, but read this. There is some app, but I can't read it.
Each improvement would have its own app.
Yeah.
So there would be the maps for the bike.
Yeah, so actually.
Yeah, but an IoT device where you would use it.
For instance, in the case of scooters, you can maybe put it.
Well, those are information studies students.
For example, bikes, you can check the surface of the path, check whether they are on here.
Yeah, and GPS and stuff like that. Great. Oh, thank you. Anyone have questions? No one's talking. Okay.
Okay, thank you.
Thank you.
Next, Valencia. Is anyone here from Valencia?
No.
Hungary.
You mean we don't have dear students, so the website, please, from this position, yes, it is better for camera.
So what is your idea for what problem application?
So what we chose, actually one of them is we have a bike sharing platform, but only one, but it's only restricted for students only. And moreover for students of the University of Debrecen, so not even smaller high school students or something like that. What's that?
Discrimination.
Yeah, exactly. And stations are not everywhere except acceptable. Like they are only at the campuses and in the main square, and that's it. So not at the tram station or the train stations where is the real fluctuation is going on. So that would be better if we would have a non-restricted bike sharing platform, which is for people who is coming from other city to travel inside the city to work and so on, and for those who are going to the train station as well. So yeah, and more bike routes as well, because the city is in the city center. It is developed for biking, but other like 2 kilometers, it's not really, it's like non-existent.
So where would you use an IoT device in your application?
Yeah, and the bike sharing and the bikes, as you just mentioned out there,
Do you have any another transport option, or you just
train, tram,
okay.
and
You think
buses.
that all the others are well developed, or
No, we don't have e-scooters, for example,
okay.
like at all. So we do miss like quite a lot of things.
Yeah.
Actually, you should ask what we have in the
Yeah.
A shorter list, huh?
Yes.
Okay.
Okay, thank
Okay,
you.
thank you.
Košice?
No.
Here, Radev? Not here. Bulgaria?
No.
Finland? No, Finland.
I'm going to use the
Charge port.
Sure.
Millä välillä sä
So we have a guy called, let's say, Bob. He lives in the city or village, let's say about 30 kilometers away from the capital city here. And his job is in this crappy office building here. He has a nice Mercedes, so he wants to drive to work. So what he does, normally he would take the car, drive through here, go through the city center to his office. Now petrol prices have risen up to, let's say, €6 a liter, and he can't afford it anymore. So with our very smart application, what it does now, it suggests the route suggestion. So let's say here we utilize existing public transportation systems, like we have, let's say we have a metro here, and we have a train from here to here. So now our application suggests the route by car. Here, there is a huge parking place. He can leave his car there. Then we have a micro journey here, and our application will either suggest an e-scooter or maybe a bike or maybe walk. Then he jumps on this, what the fuck was it, a train? Yes, again, and then from the train, there's a micro journey coming here. And then again, the same thing, it's an e-scooter, a bike, or walk, and then the metro system, and it gets to his office here. And what we do is, this is pretty similar to what we have in Finland. We have a lot of, for example, weather problems. In the winter, we have heavy snow, or we have, for example, well, heavy snow is the biggest problem. So a lot of our railway systems get blocked. So we'll have in the city already existing weather like applications and weather, what do you call them, these rotating systems that you had. So we collect sensors, yeah. So we collect the weather data, and depending on that, you know, for example, you don't want to take the scooter in heavy snow, you can't take the scooter in heavy ice, so then he suggests something else. And also if, for example, Bob didn't have a car, you could suggest maybe like a carpool thing and whatever. And
yeah, well, it's the same way also based on the Bob's user like preferences. Like if he doesn't use, for example, scooters in a month, the system would like react to it and lower the scooter suggestions to like bottom of the suggestions, or just completely remove. Also, you could like have a filtering system manually, so you could like filter things manually. We already have this in some of our apps in Finland. But yeah, I mean, is there anything into it? Right.
Okay, just question regarding the transportation options. You have all of them already implemented in Finland.
Yeah.
The cities or?
Yeah, well, the transportation systems. Yeah, but I think the thing that is missing right now is that some of these. I think there's not like app where it automatically removes,
No.
and they are not usually as like unified. You don't have like, you can't connect a lot of like, because there's stuff like Uber and stuff, we don't have it in our apps, and also there would be that benefit that, the revenue would come, that if this catches like, ground and people actually use it, then the providers of the Uber, for example, they want to get to our platform, so they would naturally pay for us to get to the platform, and then we can even take a fixed, margin from that when they use it through our platform.
Yeah. So currently all these micro journeys, they are not implemented like now. So so now this would be a real case. If I check this trip, it would suggest the train, the metro, the bus, and only the walk. So then that would be the sector where private service providers could provide, or for example, carpooling options or whatever, and that would be the revenue stream from the private sector.
Okay, thank you.
Thank you.
Osijek, Croatia.
Where? Here from camera, right here.
Croatia and France cooperation.
Yes, so Osijek has a lot of like public transport already implemented pretty well, but like where is it lacking is that a lot of people from rural areas come to work to the city, and they usually arrive by car. There are some like train station options, but only on a very limited like route. So people that live in villages that are above or below the train line have to ask someone or carpool to the train and then take the train to the city. So we would solve like the last mile of their travel problems with like a MaaS application. It would probably be implemented in a form of like some kind of scooters that can be dropped off at the train stations and picked up there, and maybe even like when they take them home, they take the same scooter they got home with back to the train station, and then it can be reused. And like the pricing would like have to be adjusted based on the conditions and the weather, but it can maybe like even be implemented that such people serve as like delivery drivers for isolated villages to take some stuff from the city to the village where it's necessary. So like the price could be offset a bit, and yeah, that's like one idea. The other one?
Yeah, so we thought together about an idea that would go a little further than only the mobility aspect, but on the food delivery aspect, by thinking about an IoT devices who can have a sensor about like food temperature, and like a little oven device who can start his action, like try to reheat the food exactly at the perfect moment, so that the cheese can be very melty at
the perfect moment.
At the perfect moment, yeah.
Great, great idea.
Yeah, great idea.
That's it. Thank you.
Germany? No.
No, that's it.
Croatia, Zagreb.
Oh, Zagreb. Oops.
Okay, so near our faculty there's like a box with a lot of sensors that measure nitrogen dioxide, sulfur dioxide, carbon monoxide, also humidity, temperature. So actually we can get data of air pollution, like real-time air quality index, and we could use like an app to collect that data and I don't know, inform citizens about pollution. Should you stay at home? How could you use bicycle or cars to go to work? Just to improve the health and the environment. That's it.
Ivana has
questions.
Ivana wants to grill you.
Let's talk a little bit about transportation options. Okay, this IoT thing about health is okay. I agree with all
it's
that.
more like,
What do you think about the?
Yeah, but with the air quality index, like if it's very high, the Google Maps or whatever MaaS application would suggest to go by bike, so we don't pollute any more. I mean, there's like.
But
more
is it
long-term
good for the
solution.
user? The air pollution is already there, and you're telling him to go by bike and breathe in even more.
I mean, you could also.
Yeah, that's the best.
Well, actually, one point, like Apple already does it in the app weather. Like I have it for every city almost. Like the pollution index, whether you should stay home or not. Like even it's for Valencia here, actually.
Yeah.
What is the weather in Valencia like? Tell us.
Like what is the pollution?
Yeah.
Like it is green right
Okay.
now, yes, but it measures actually in the city, so.
Great.
Yeah.
Okay. So that was it. Thank you for your attention and your ideas and your work, and now we can go to lunch.